Hello everyone. In this session, I'm going to do a sample deployment of an API gateway with focus on security. We are going to take an existing serverless application, which we have built in one of the previous videos in this channel and those videos that I did. And it's a standard serverless application deployment with API gateway, Lambda, DynamoDB, and it is implemented using best practices, but is not as secure as it could be. And we're going to take this and make it look like this. This video is actually a continuation of the API gateway security video that I have done previously. That video talked about the theory and principles of how to secure your API gateway. And this video is more of practical of how you take an existing serverless application, or if you're building a new application, and apply all those things that we learned in the previous video and make your API gateway instances much more secure. So if you haven't actually watched that video, I would recommend that you watch that video, because it talks about the theory behind the things that we would be doing. And then it's going to make more sense why we are doing a certain way in this video and which security principle it is linked to. I also want to mention that this video is intended for more advanced audience. So some of the things that are done in basic videos, like you talk about one service and then you enable it and then you show it running. So those things I would not be doing. Everything is CDK, and that is primarily because the serverless application that I am taking was built in using CDK. So it's not a CDK tutorial, and it's not also like a step-by-step thing. The idea is to cover these concepts and show an example of how the security concepts can be implemented in an actual application deployment. So getting to the main topic of our discussion today, let's understand what have we done to this standard serverless application and to make it more secure and incorporate this architecture. I have these listed here, but actually I realized that it would make more sense if we have it side by side. So it's a little smaller, but at least we have it side by side. I think it will be easier to explain and understand this way. So first thing to understand is that we are locking the API gateway to the external world. And we are locking the API gateway to the external world by adding a Cloudfront distribution in front of the API gateway. So users are going to send requests to our API gateway through the Cloudfront distribution only. The way we are locking it is by using an existing pattern, which is by requiring all requests to have a specific security token. And that security token is only going to be known to the Cloudfront distribution. So although this API gateway is going to have a public endpoint, but users would not be able to send requests, or they would be able to send requests, but they would get denied because they won't have the security token, which is a secret and shared only with the Cloudfront distribution's Lambda edge method, which is going to be injecting that token in all the requests. Now you see a secrets manager icon here. The secret value would be stored in the secret manager, and the Lambda edge function is going to have access to the secret so that it can inject it. And similarly, the authorizer Lambda, the custom authorizer, is going to have access to the secret so that it can get the secret value and verify that the correct secret value is associated with the request. This also takes us to the other important thing that we have done, and that is not mentioned in this list here. Should have been mentioned because it is a very important aspect of our architecture, but it is mentioned here in our diagram. So we are using a custom authorizer. Previously in the original application, we are using Cognito and Cognito only for authentication and authorization. Here we continue to use Cognito, But in addition to Cognito, we have also added another layer of authorization, which is this secret token based. So users would still need to log in and send the access token with their request. And then if they will come through the Cloudfront distribution, the Cloudfront distribution is going to add the additional security token. So both need to be present and both would need to be valid in order for the authorizer to authorize the requests. Adding a Cloudfront distribution also provides another advantage, and that is additional DDoS protection. This once again is also a common pattern used for DDoS protection to add a Cloudfront distribution, because then all the requests would be served from the edge if you have caching enabled. In addition, we have also added usage plans. This is an API gateway concept, and with usage plan, we are able to implement throttling at the user level or at the client level. So we can have a gateway level throttling or rate limiting, and we can also do client level rate limiting usage using usage plans. Usage plans makes our API gateway more reliable and more secure. It makes it secure because if requests do not have a valid usage plan identifier, then those requests would be denied. And it makes it reliable because of a bug or rogue behavior from one customer doesn't bring down the API for the entire customer base. So if you have like a bug in one of your client's code that it goes in some sort of an infinite loop and keeps sending requests and it brings the API gateway down if we don't have rate limiting enabled, right? So now we have protection against that scenario, and your client's API credentials could get exposed, right? And the hacker might then do like a sort of like a DDoS attack on our gateway, but with the usage plan in place, they would not be able to bring the API gateway down because of the rate limiting that we have enabled for that specific customer. We have also added request validation, which is another API gateway feature, and it validates the request content before it reaches our code. And if it doesn't comply with what we expect, then the request never reaches our application code and an error is returned to the user. It makes it more secure because when we are going to receive the request, it is going to have exactly data that we expect. And bad requests are never even going to reach our application or Lambda code. Last but not the least, we also are going to add a web application firewall and AWS WAF, and it is going to protect us against common known exploits, bad IPs. So we have a bunch of things that is going to provide protection against. With WAF, we can also implement rate limiting. So we can add additional DDoS protection through WAF as well. Next, let's get into the implementation part and see how we have implemented this architecture in our CDK app. So this is where if you go through the CDK serverless application video series, it's going to help you understand the CDK code, because here I'm assuming that you have that knowledge. So if we go to our application source code, you will see we are creating this one main application stack, and then we also create this WAF stack, which we're gonna discuss very soon. But let's get into our main application stack. And at a general level, we have these three functions which does what is being said. That is, this one is going to create persistence, which is DynamoDB. This will create our authorization, and so on and so forth. Okay. I first want to show our custom authorizer, and that happens in the REST API method. So here you are seeing we are creating an instance of request authorizer. Previously, we had something called CFN authorizer, which is like the standard authorizer. And forgive me if I am not using the right instance name, but you can go back to the serverless video and you'll see. And actually this code is in GitHub as well. So anyway, for this purpose, if we want a custom authorizer, then we would need to use a request authorizer for that. And here we are specifying the identity sources so that the API gateway instance can pass these header values to our authorizer function. Because as I mentioned, we are authorizing based on both of these. So we are creating the authorizer here, but the implementation is in a separate file. And this file is called authorizer.ts. And here you will see in the implementation, here we are extracting the authorizer token, the standard OAuth token. In addition to that, we are also extracting another header value, which we call source identifier. And we are going to compare both of these header values. And as I mentioned in the introduction, this value comes from a secret. Important thing to understand is that we need to get the value of this secret at runtime. So this is what this call is doing. And because obviously secrets can definitely not be in our source code, they can also not be as environment variables in our Lambda. That's how I've initially implemented this. And then after implementing everything, I realized that this is not secure because an environment variable is not stored in encrypted form. Although I'm sourcing the value from the secret, but when we create the Lambda and say, okay, this environment variable, we have this value, then that secret is getting decrypted and not being stored securely. So that is why we need to make this call at runtime to the secret store to get the value. Okay. And yeah, after that, it's just doing the comparison. And then here it's basically doing the cognito verification as well. Lastly, this method needs to return a policy which will tell API gateway which specific permissions does this user have, which in our case is going to be permission to invoke this API. And that is what we are returning. Next, I want to show the Cloudfront distribution. So we'll go to the main constructor function. And here you are seeing the create Cloudfront distribution method. So one thing to note here is that in the origin header behavior, we are allowing these two headers because these are the two headers which would be needed. One is the API key and the other is for the usage plans, and the other is the source ident header value. So these headers with this, they would be passed to all the requests that would be made to our origin, which is our API gateway instance in this case. And obviously an important thing with our Cloudfront distribution is this method, which I call the inject headers. That was my new friend, my parrot that I just recently got a few months ago. 1 second. Come on, Oscar. Okay. Yes. So her name is Oscar, and the story behind this is when we got her, we thought she was a he, so we named her Oscar. And then when I took her to the vet, she did the blood work and she said no, she is a she. And then I basically looked up, and Oscar can be a female name, so we just decided that we're just gonna continue naming her Oscar. And yeah, so she basically stays with me in my office, and then she also comes out and just hangs out with the entire family. Okay. So now I'm gonna put her back and then continue with our discussion. So we were talking about the important Lambda edge method of called inject header, which injects the source ident header in all the requests. Quickly, we can peek into the implementation. Very simple, but does a very important job. And I actually tried to make it a cloud function because they are more lightweight and run more closer to the user. But I actually ran into multiple issues. I can't remember what those were. So that's why I just switched to using Lambda edge method. Yeah. So one thing which I didn't point it out is that inject header this method, this Lambda edge method, also gets a secret from the secret store. So that is very important. Now in the code that I have in GitHub at this point, there is no caching enabled. So at this point, I've tested it with no caching enabled, but we should be able to enable caching. I don't see any reason why that is going to create a problem. And that actually is going to provide us the DDoS protection that we discuss from the DDoS protection which we get from Cloudfront. Very important thing to note is that when we create the API gateway instance, we want to make sure that it's regional edge based. Its endpoint is regional, not edge based. This is the setting. Because if we are going to do edge based, then it is actually going to use a Cloudfront distribution, but not the one that we have and we can customize. It would be one of AWS's Cloudfront distributions, which are hidden to us. But that's how they implement the edge based endpoint using Cloudfront distributions. Let's also quickly look into how we incorporated the usage plans. So there's this method which gets invoked at the end of the create REST API method. And here's the code for setting up the usage plan. It's pretty self-explanatory. One thing to note is that to use the usage plan, we need to have API gateway and API key, which is what we do here. And then we basically add this API key to the usage plan. I also talked about request validation, which is a very important feature. It basically makes our code simple because we don't have to add those checks in our code. And it also protects us against bad requests and our code doesn't get invoked. We don't incur any compute cost. So it provides that benefit as well. So let's search for value. So just quickly, the flow here is this method gets invoked when we are creating the post orders endpoint. We don't have it on put, but in an actual implementation, we should have it on all relevant endpoints. So if you go to the implementation of this method, pretty self-explanatory. We need to create a schema. And then we create a model object, pass that schema. We also create a request validator and associate it with the API gateway instance. And here we are returning the request validator and order model. I don't know why we are not doing the association right here. Oh, it's because the calling code knows which endpoint to associate it with, right? So yeah, so here when we add the endpoint, we are passing the request validator to use for this specific endpoint and the model as well. Last but not the least, we will talk about the WAF, which provides us protection against a lot of kind of exploits. And I showed you this file in the beginning. Let's go to the implementation. I implemented WAF as a separate stack so that depends on the main stack. Once that gets created, and then we are going to create the WAF. And here you are also seeing that I'm also adding this dependency explicitly. I'm not sure if that is required, but it's just more verbose code. So I added a bunch of managed rules, but If you have used WAF in the past, you know you can add your custom rules or rules from other third party, right? You can add rate limiting. So you get all the things in your API gateway, the protection which WAF provides. Okay, so this covers all the implementation specific things that we had to do to implement the architecture that we initially discussed. Let me bring that architecture diagram back up. So here's that diagram again, and everything we discussed like in the implementation, now this is going to be more clear and it's going to make more sense. Okay, last thing that I would like to do, since this is CDK code, we can just press a button and the entire application with everything is just gonna come up. So let's do some magic. So here's our command line that we're gonna use to run CDK deploy, and we have the AWS console opened behind it. Let me go to the CloudFormation stacks. We don't have anything for our serverless application right now. And let's run the command and we're gonna see the CloudFormation stack for our application get created. So if you run CDK list, it'll show the 2 stacks that we are creating. And all we gotta do now is just deploy all the stacks and wait a few minutes. But we can, once we acknowledge this, we're gonna start seeing the CloudFormation stacks. Here it is. So I'm gonna pause this recording and then come back once everything gets created. So as expected, after 367 seconds, everything got created. And let's just peek into our resources. Go to the stack, resources, and where's API gateway? Shop API. So here's our API gateway instance. And this is our Cloudfront distribution. Let's make some calls to our application. In order to do that, we will have to create a user incognito. Search for pool. So this is the user pool, and they changed the UI recently. It's looking better. Go to the login page, sign up. Okay, signed up. We have our ID and access token. I will copy it somewhere. I have the ID token copied in my clipboard. Now we are going to make some calls. Let me actually set up my Postman and then come back and we'll make a few calls. Okay, so I've saved certain values. I've created them as variables. I will do one thing. I will copy the endpoint values and then paste them here. So this is the endpoint for my Cloudfront, which is what we should be using. So we'll first use that, And I will also copy my API gateway endpoint just to see if I am able to directly invoke the API gateway. I should be getting an error. So if you go and look into the post call, so basically I'm using the variable that I just saved, and if you go to the headers, you will see that I'm using the token. We also need to pass the API key. That part we haven't done, so let's do that. So I'll go to the stack, search for the API key. This is for the usage plan. Search for key. And I'm going to copy it in my clipboard. And then save it in this variable. I'm passing the API key, the source identifier. I am not supposed to be passing here. It doesn't, and it won't matter if I pass it, because it would be handled by the Cloudfront distribution. And let's make a call to our orders endpoint, and this should succeed. Okay. Now let's do a get call. Let's create another order. So we're gonna create two. The second one, and let's make a get call. It expects a range. Okay, this is good. So it is returning the two records that we just created. Now we are going to check some error scenarios. So we are going to make a call directly to the API gateway. Let me actually save it here. And then the host I'm going to change to the API gateway. And I should be getting an unauthorized error here, because now I would be making the call and not passing the source identifier header and a valid value for that header. And we should be getting an error by our custom authorizer. So everything else remains as is. Our host has now been changed to the API gateway endpoint, and let's see what happens. See, we got unauthorized as expected. Now let's also test another error scenario. First, let me restore to the correct host, which is of the Cloudfront distribution. And let's just make sure that this is working. This is good. Let's do another post order, but pass an invalid request body. Let's just not pass the quantity. And here we should get an error, because remember we set up a request validator that checks the request body is as expected based on the schema that we have passed. So let's see what happens. So yeah, we got an application level error of 400, and it's complaining about invalid request body as expected. Let's pass the correct request body, and it's getting created successfully. This brings us to the end of the current video. Thank you for watching. And if you like the content, don't forget to subscribe to the channel. And I look forward to seeing you in the next video. Thank you. Bye.